Hey folks, okay, well let's get a little bit more practice with structs this time around. So I want to deal with a kind of a more complex problem where we'll try and build up a solution to the problem from start and using a hierarchy of structs and that kind of thing. I also want to talk a little bit about a couple of points that we didn't get into with structs. That's the idea of assigning one struct to another or using structs as a return type from a function. So I think that's where we will go here. Let me ditch that. Let's take things in kind of reverse order here. So let's take a look at assigning structs to other structs. So this is something that you can actually do. So if you've got a struct of info items or a struct of points or a struct of whatever it might be, you can take two variables that are of that type and assign one to the other. And essentially what happens is it goes through and does the assignment field by field. So it's pretty much the same as for each field doing, x dot whatever is assigned to y dot whatever. So just as an example here, if we have our struct type here, so we've got some struct and it's got two fields in it. Right? It's got one that's a float and one that's a string, let's say. And we go through and we assign a value to one of them. So here I've just done it as part of our initialization. So let's create a x is one of these items, and it's going to start off with 1.2 in the float and the string foo in the s field. So x has got values in x.f and x.s, and then we've got another one. Y is also one of these items. So you can actually just say y is assigned x, and what it will do is field by field copy the contents of x into the contents of y. So it's the same as doing x.f is assigned to y.f and x.s is assigned to y.s. So again, it just goes through, does a field by field copy. Now that works fine as long as the assignment operator works correctly for each of the different data types in there, for each of the different field data types. So where you get into trouble is where you have things like arrays or other more complex data structures as part of your struct. So in this case, let's say we've got a struct that's got an array and a float and a string in it. So if we create two items of that type, A and B, if I try and use assignment to copy one to the other, to say, B is assigned to A, that works fine for the float and the strings fields like we just saw a moment ago, but you can't use the assignment operator, the equals sign, to assign one array to another. So this will not successfully copy the array from B to A. So that's where you have to be aware of the risks of just using a simple assignment. So if you've got simple primitive data fields, this is okay. If you've got more complex ones, then you will run into issues. All right, same sort of idea. We can use a struct as a way to kind of get around the whole C++ idea that you can only return one value from a function. So if we've got a bunch of values that we want to return from a function, one thing we can do is bundle them all up into a struct and then return something of that struct type. So again, let's say we've got our sum item as our struct, and again, it's got a string field and an int field. And we want a function to return one of these things, to return one of these beasts that's got both a string and an int in it. So I'm just going to create my little fake function here. So get an item is going to return one of these sum items. So inside, we declare a local variable to have the actual value, to store the value someplace. Create a local variable, we prompt the user, enter the string, enter a number, and we read them in. And so we're storing them in our local variable. And again, that variable only exists inside the function. But what we're going to do is return it. And again, that basically goes through and says, okay, well, let's copy whatever's in X, we'll copy back to wherever this get an item is returning to. So say in the main routine, we say something like my item is equal to, and we call get an item. So get an item goes off, gets the user to enter the string and the number and stores it someplace, and then returns it where those two values get copied into my item. So you can actually use your structs as return values, as return types in C++. Again, with the caveat that you've got the same issue we talked about for assignment, where we can't have more complex fields in our struct. So if my struct had an array as one of the fields, then this wouldn't work because it wouldn't copy that array back properly. So within that limitation, you can use structs as a return type. All right. So that was the, I guess, the two other theory points that I wanted to bring up, the kind of implementation things that we can do. I did want to get into just kind of maybe one more design example using structs. So what I thought was, let's say we're faced with the problem of detecting collisions between objects. So this comes up all the time in games or in simulations where you're trying to have a whole bunch of different things going on and you're trying to figure out when one thing bumps into another. So, you're either working in 2D space or in 3D space, and you're trying to keep track of all of these different objects and figure out when they run into each other, when they bump into each other, when they collide. And so we'll work through a simple example with that where, again, we're going to keep the, the complexity down here. Let's simply deal with circles in a 2D plane. So just two-dimensional circles, and we're just going to have a bunch of them that are stationary, and we're just simply going to go through our list of circles and figure out which ones overlap. So if you're getting into the movement side of things, then you also have to detect when they start to overlap, but we'll leave that for now and just see what we can do in terms of figuring out, okay, you give me 50 circles on a 2D space, which ones are bumping into each other right now? So that means that we need a way to model a circle. And one of the simplest ways to do that is to say, well, let's keep track of where the center of it is and what its radius is. Right? So if we know its x and y coordinates in this 2D space, and so for the center point, and we know the radius of the circle, then we can do whatever we want with it, right? We've got enough information to keep track of where that circle is and how much space it covers, exactly what space it covers. So if we can think of a circle as being a point, this xy coordinate, and a radius, we can model it. Sounds like a good candidate for a struct. And for the point itself, again, we can take the same sort of idea. Well, if I want to model a point as, an xy pair, then my circle can be a point plus a radius, and my point can be just two floats. So let's give that a try. We'll create a struct for a point, and then a struct for a circle that uses our point. Right? So for our struct, again, pretty straightforward. For our point, rather, pretty straightforward. We just have an x coordinate and a y coordinate. Let's make them both floats. And at first, let's just set up two functions, one to fill in the values for a point, and one to print them out. So to fill it in, again, we just make sure it's passed by reference, and we'll prompt the user, enter the x and the y coordinate, and we'll just read them in. And of course, you'd want to add error checking, but for the fundamental ideas, it's pretty much just fill in the values, and as long as it's passed by reference, that's going to work. And then printing them out, same idea. We'll just print out the x and the y in brackets, so the bracket x comma y, and then our closing bracket. So it's just a couple of couts. So our basic work with our point struct is pretty straightforward. Then for our circle, we'll just say, well, our circle is a point that represents the center of the circle plus whatever the radius is. So we'll throw in a float for the radius. We'll have our point P, and we've got the idea for a circle. Again, we'll come up with a function to fill one in and a function to print one out. Well, to fill it in, again, we'll just say our circle gets passed by reference, and we're going to fill in the contents. We can call the fill function for a point and say, okay, please go fill in the point for me. And once that's done, I'll get the user to also enter the radius. So again, these two basic steps, right? Call to the function to fill in a point and read in whatever the value is for the radius. And then same sort of idea, if we want to print out the contents, we can go through and say, okay, well, let's do a print function where we're getting our circle. It doesn't have to be passed by reference this time because we're not changing anything. We'll call the print function for a point and just pass it the point that's the center of our circle. Right? So you go print off the center coordinates, and then I'll print out the radius as well. So again, we can come up with the basics for our points and circles, and those aren't too complex. Then if we want to have, let's think about the structure for figuring out overlapping circles. So let's say we get a whole bunch of circles and we want to figure out when they overlap. Well, I'm going to go through, and apologies for the denseness of this, but I'm going to go through and think about my main routine, and then as I'm going through writing my main routine, I'll think about what kinds of functions I need to be able to detect all these collisions. So what I'm going to do is I'm going to assume I can come up with a function where you give me two circles, two specific circles, and I'll tell you if those two overlap. And so what I'm going to do is just use that function over and over again to check all of the different pairs of circles I wind up with. So what my main routine is doing here is we've got our usual idea of let's create an array of circles. So I'm going to say 10 circles, for instance. And so we'll just create an array of 10 of these beasts. And then I'm just going to use that fill function that we had on the previous slide to go through and fill in those 10 circles. So let the user enter the data for the 10 circles. So now I've got this sort of representation of my 10 circles wherever they are on this 2D space, and I want to go through and figure out if any of them overlap. So what I'll do is look at each possible pair of circles. So I'll go through each circle in the array and compare it to each of the ones that's further down the array. That way I don't have to worry about sort of running into collisions twice. Going through and saying, oh, well, circle 1 overlaps with circle 5, and then later on turning around and saying, oh, circle 5 overlaps with circle 1. So I'm going to go through, see if I can identify each pair, and for each pair, I'm going to see if that pair overlaps. So that's what I've got here, is I've got one outside loop to pick the first circle in the pair, and then an inner loop to pick the second circle in the pair, and I'm going to assume that I can write this collision detection function where I give it two circles and it tells me if they overlap. So I've got this outside loop that says go through all of the circles, and then an inner loop that says, okay, compare that one to all of the circles that are later in the array, and then I'll just say, okay, well, does the current pair of circles overlap? Does the first circle in my pair overlap with the second circle in my pair? If I can write this collides function. And so if that function returns true, then I'll just say, okay, I've detected a collision between whatever the first circle is and whatever the second circle is in my pair. And so if I can write that collides function, then my problem's solved. Right? Then I can go, now at that point I've got everything I need to go through and say, well, get my list of circles, I've got them modeled as circles and points, go through and find out if any pair of them overlap, and for every pair that overlaps, print out the details. So that means that we need to be able to detect a collision. Well, it's actually relatively easy if we think about it from the point of view if I've got two circles and I know where their center points are. If I can figure out how far those center points are from one another, and I know what the radius is for each circle, then I can tell whether they overlap or not. If the two center points are, let's say, distance 5 apart, and the radius of circle 1 is 3 and the radius of circle 2 is 4, then they're going to overlap because the sum of the radius is 3 plus 4 is 7. Well, that means that there's not enough space in between them for them to avoid each other, if you like. So I can figure out if these things overlap by knowing the distance between them and what the radius is for each circle. So my collides function is going to work fairly simply based on the assumption that somehow I can write a function to compute a distance between the two centers. So if I can figure out how far apart the centers are, this function is going to work. So Now I'm making an assumption about yet another function I can write, but we'll get there in a sec. So I'm going to have this collides function. Give me two circles, and I'll return true if they overlap, false if they don't. So what I'm going to do is call this other distance between function that I haven't figured out yet. So that's going to go off and compute the distance between the 2 points that are at the centers of these circles. And it's going to give me back that distance, and I'm going to compare that distance to the radius of circle 1 plus the radius of circle 2. If the distance is smaller, then there's not enough space between them, they've got to overlap. And so I'll return true. Otherwise, under any other circumstances, the two circles are far enough apart that they can't possibly overlap, and so we'll return false. So this works if I can go through and figure out my distance between the two circles. And again, this is often the kind of cascading effect that we run into when we're trying to solve our problems. Right? We come up with a high-level view of what to do, and as we're working our way through, we go, oh, well, this will be easy if I know this one other thing. And so I write my current function based on the assumption that I'll be able to figure out this one other thing. And then later on, I go off and try and figure it out. So that's what we'll do now. Let's see if we can figure out the distance between 2 points. So if I want to get the distance between 2 points, that's actually a fairly well-known formula. So if I've got 2 points, x1, y1, and x2, y2, if I take x1 minus x2 squared plus y1 minus y2 squared and take the square root of all of that, that'll give me the distance. So x1 minus x2 squared plus y1 minus y2 squared is essentially equal to the distance squared. So if I've got this as my formula, that's going to make it fairly easy for me to figure out the distance between the 2 points. Right? I just compute this and take the square root. So if you've passed me these 2 points, in our case, we know it's actually the center of the two circles, but it doesn't matter. This is just any 2 points. You give me point 1 and point 2. Then if I take the distance between the two x's, so p1x minus p2x, and then square that, and I take p1y minus p2y, and I square that, and add the two of them together, that gives me the square of the distance that I'm looking for, and so I just return the square root of that. So we'll have to include our CMath library, but again, this is a relatively straightforward computation, and so now we've got the ability to compute the distance between 2 points, which allows us to figure out if two circles collide, which allows us to have our loop that goes through all pairs of circles and figure out exactly which pairs collide and which ones don't. So again, we can go through and just kind of piece by piece work out a solution to most of our design problems. And again, the individual functions have all been relatively straightforward. Right? We look at our fills and our prints. Those are nice and straightforward because it's just thinking about what's relevant to a point or what's relevant to a circle. And when there's more gory details inside to work out, I call another function to deal with that. When I'm looking at my collision, again, I just think of it in terms of circles and say, okay, well, if I can figure out the distance between their center points and call some other function that deals with the inner workings of that, I can just compare that to the radius. And so again, my collision function is straightforward. And again, my points function, the distance between 2 points, it doesn't care about circles at all. It's just saying, okay, well, you give me the 2 points and I can figure out how far apart they are. And again, that's relatively straightforward. So we can come up with a reasonable structure for solving problems like this. Let's just take a quick look at sort of whether or not this works. Where did I put this? Circles. Okay, so let's take a look at our circles. If I can type our circles.cpp. So this is essentially the code that we were just talking about. So we've got a struct for a point, and it's got the xy coordinates. We've got a struct for a circle that's got a point for the center and a float for the radius. We've got our fill function and our print function, and again, the fills. So these two are for points, and the fill has to be by reference. And our fill and print for a circle, and again, the fill is by reference. A Boolean function called collides that returns true if two circles collide and false otherwise. And then a function that returns a float, the distance between 2 points. So again, we've got this half dozen functions to write, and we've got our main routine where we're going through and saying, okay, let's create a bunch of circles. I went with 5 instead of 10 because I want to minimize the amount of typing I do when we run this for practice. And again, we're just going to get the user to enter the data values for our 5 circles. And then we're going to go through, and this is that nested loop where we're saying, okay, for each possible pair of circles, we'll have the first circle in the pair and the second circle in the pair, and we'll just go through all of them for the first, and then everything that's later as the second one in the pair. So for each possible pair of circles, see if those 2 circles collide. And if they do, we'll print out, okay, a collision detected between whatever the 2 circles are, and we just call the print function for circles to print them out. And that's pretty much the idea. So again, main routine is not too bad, considering the task we're trying to achieve here. Again, our individual fill functions, essentially just some couts and cins, where we're filling in whichever item it was. So for the point, enter the x and y coordinates, read them in. Of course, you'd want to add error checking for this. Same idea for the circle, right? To get the center point, call the fill point function to fill that in, and then get them to enter the radius as well, and add the error checking for that, of course. The collides function is pretty much exactly as we described. We'll call that distance between function to go off and figure out how far apart the centers are, and compare that to the sum of the radius of the first circle and the second circle, and we can figure out if they must overlap or not. And then again, to compute the distance between them, right, we've got 2 points. We want to figure out how far apart they are. We take the difference between the 2 x coordinates and the difference between the 2 y coordinates, square them and add them together, take the square root of the whole thing, and we've got our distance between. So hopefully this actually compiles and works. Circles.cpp, our wall and wextra, and I don't know, let's call our executable circx or something. And so far so good. So see if we can run this, and it should get us to give our 5 points. So let's pick some things where we know whether they overlap or not. So I'm going to give 5 circles. Let's have one at coordinates 1, 1, and a radius of 1.5. So that's got our x coordinates, our y coordinates, and our radius. Oh, I kind of shortcutted there and typed in the radius on the one line there, but let's, so we've got 1 at 1, 1, it's a radius of 1.5. Let's get 1 at 1, 3, and give it a radius of 1. So now those two should overlap, right? The one at 1, 1 and 1, 3 are distance 2 apart from each other, but one of them is a radius 1.5 and one of them is a radius of 1, so the combined radius is 2.5. Those two should overlap. Let's throw in another one, let's say 3, 4, and a radius of 2. So that one should overlap with this one. Again, their combined radius is 3, and they're less than a distance of 3 apart from one another. So we should get an overlap there. So the first point should overlap with the second, and the second should overlap with the third. And let's get a couple that are sort of outside somewhere. So let's throw one way off at 2, 7, and a 1, and one at, I don't know, 4, 1, and let's give it small radius 0.5. So those two should be outliers and shouldn't overlap with anything, assuming I got my math right. Let's see, so yeah, going through, so it went through all the different pairs of circles, right, or pair nested loops there, and it found that that first circle did overlap with the second one, and found that the second one did overlap with the third one, but the other two didn't overlap with anything. So again, we can go through and come up with a solution to these kinds of problems. All right, I will leave that there for now. This isn't a terribly efficient solution if you're trying to do this in real time for a complex system, but it's a good start for us. All right, I will leave it there.